This week we will be discussing subqueries. A subquery is a query inside of a main query. Sometimes it's also referred to as a nested select. There are three main ways that we can use subqueries. We can use them in our where or having clauses as part of a condition. We can use them as a calculated column in our select clauses. And we can use them as a source of the data for our queries in the from clause. When we use subqueries, we have to enclose the query in parentheses. They can be used to simplify complicated queries, and they can also be used when a query is based on some sort of unknown value. So we'll do some examples with those. There's a number of different types of subqueries. So there are single row subqueries, which return one column and one row of results. There are multi-row subqueries, which return multiple rows. Multi-column subqueries, so they could return multiple columns and multiple rows. And then separate from those, we have correlated subqueries and uncorrelated subqueries. Uncorrelated subqueries can stand alone, but correlated subqueries cannot. So our uncorrelated subqueries can be run separately and get values. When we have these, the inner query, or the nested select, is processed first, and then the results are passed to the outer query, which is then executed. So let's do a couple of examples with those. Let's start with a single row subquery. So something like, let me bump up the size here. What products cost less than Jack's New England clam chowder and are in the seafood category? So when we have our subqueries, we have to identify what our two queries are. So we want to know what is the cost of Jack's New England clam chowder, and then we need to figure out what products in the seafood category cost less than that. So I'm going to start by writing that query. Select from products, P dot unit price, for P dot product name equals Jack's New England clam chowder. Okay, so this costs $9.65. So the main query will eventually ask what products cost more than that, but let's start by substituting that value. So select from products, P dot product name, P dot unit price. So we have to join to the categories table to be able to pull the seafood category. Products join categories, see? Use join on the category IDs. Where C.category name equals seafood and P dot unit price. We want less, okay. Unit price is less than $9.65. So we could write this query and that would give us the answer. However, if the price of Jack's New England clam chowder ever changes, and we need to know this information on a frequent basis for some reason, this query wouldn't be accurate anymore. So we can write it as a subquery. We're going to put it together. So this is my main query. And instead of this 965, I'm going to put the query that generated that value. And just to make this less confusing, I like to tab these in. So we should get the same results here. So that's a single row subquery in our where clause. It returns exactly one row and one column. So with our single row subqueries, they may only return one result to the outer query, and we can use any of our single row operators. So single value comparison, equals, less than, greater than, not equal to, any of those. So we can do the same thing in our having clause. So if we want to know what countries have an average freight that is higher than the average for all countries. Okay. So the first thing we have to do are two queries. So query 1, what is the average freight for all countries? And query 2, what countries have an average freight that is more than the value? So we'll come back and put that value in. So query 1, average freight for all countries. So freight is in our orders table. Select from orders. I want the average freight. So 78.19 we'll round up. So what countries have an average rate more than 78.19? So select from orders. And we moved our country table, our countries to its new table, so we have to join there. Join country continent, that's what mine is called. Yours might be called different, or if it's still in your orders table, you can use that one. So I want the country name. I want to know the average freight. Since I want this by country, I have to group by the country name. And I want the records where it's higher than this amount. So this is the column I want to compare to. That's an aggregate function. So this goes in a having clause. So there's the information. And I could cast this to get rid of my extra decimal places. But again, this value could change and will every time we have a new order. So if this is a query we run frequently, we want to put these together so that will always be correct. going to take my main query, and I'm going to take the query that generated this value, and I'm going to paste it. And I'll get the same 5 rows. Right, so last single row subquery we'll do here. We are going to have a subquery in our select clause. So display the profit, the average profit by category, and the overall average profit for all products. So this is just going to be based on individual products. So select from products, join categories C, use join on the category IDs, I want to see the category name and the average profit. So profit is P dot unit price minus P dot wholesale price. And I need to group by my category name so that the average is by category. But I also want to see the overall average. So this is our overall average is going to be simple. So select average profit, so same calculation. So $5.98, $5.99. So I could, in my query, just simply put $5.99 as the overall average. But again, that's going to change as we add new products or we change the pricing on our products or the wholesale price that we're getting. We put it together. Here, I'm just going to use it as a calculated column. So I put it in my select clause. I put it in parentheses. And then I should give it an alias. Now when I run this, I will see that same value for every row. So again, each of these are uncorrelated subqueries. I can come in here and run this subquery independently. It doesn't depend on the data in this outer query to run. So, multi-row subqueries. These could be correlated or uncorrelated. We'll do a few more uncorrelated examples. These are going to return more than one row of results. So we can't use equals, not equals, less than, greater than, equal to, any of those operators. So we would use in, not in, any, all, or exists. Any and all are so very rarely used, I'm not going to cover them. In the years that I've done queries, about 10 years now, I have never had any reason to use any or all. So we're going to talk about in and not in for our uncorrelated subqueries. And when we talk about correlated subqueries, we'll use exists. We can't use multi-row subqueries in our select clause. When we use a subquery in our select clause, it can only return one value. Otherwise, we'll get an error that says subquery returned more than one value. That would be a problem. So let's go ahead and do an example with that. Let's say we want to know which products were ordered with chocolate or chocolade. So to do this, we need to find which orders contain this product and then find the other products on this order. So orders for chocolate. Come back and clean that up later. So from order details, join products. Those join on the product IDs. Where p dot product name equals chocolate. And all I want is a list of orders. So we've got 6 orders for that product. Other products on the same orders. So it's going to be most of this query. I want to see the product names. And we probably just want to show the unique ones, so distinct. And to do that, I would say where, well, first we want to exclude chocolate because we know that that was ordered and we don't want to see it. We want to see the other products ordered with it. So where the product name isn't chocolate, and the order ID is in this list of values. So if you had more, this would really be a pain. This isn't quite so bad. I can just come in and put my commas in. But again, as this changes, this query would no longer be accurate. So here's my products that got ordered there. So instead of listing my order IDs, I'm going to substitute my subquery again. And when I run this, I'll have the same results. But if another order gets added with other products, they would now show up. So this is when we're using subqueries to find something based on an unknown value. The value of these could always be changing, what the order IDs are, the value of the average profit will always be changing, the value of the average freight, so on. So we could do the opposite. What products were not ordered with chocolate? And we'll hit up exists in a couple minutes. So another type of subquery. When we use a subquery in our from clause, it generally has a special name. You can call it a derived table. Sometimes it's called an inline view. Basically what we end up doing is creating a table on the fly and using that as the source of our data. So if we want to use something in our outer query from that derived table, we have to select it in our subquery. We have to have an alias for the derived table. It could be the only thing in our from clause, or we could join it to other tables. So let's do an example with that. So order total is something that we calculate frequently that can cause some issues with grouping or just a lot of ugliness with trying to do a group by and have lots of columns. So one way we could do this, let's say we want to display each customer, their grand total of all orders, and their average order total. So we can't do this without a subquery because of this average order total. I could get an average line total, but if I want to know what did they spend on all of their orders as an average, I can't do an average on a sum. We can't nest our aggregate functions in SQL Server. So what I'm going to do is I'm going to create a derived table that's going to calculate order totals and then join that to my customers table. So let's go ahead and do that. What my derived table is going to do is calculate all of the order totals. So select from orders O.order ID, and then order total is sum. Actually, we want to use order details here. Unit price times the quantity times 1 minus the discount. And then I need to group that by the order ID. That's our order total. So each order is going to be listed and its total. So if I want to display each customer at their grand total of all orders and their average order total, I need to do some joins here. So this is going to become my derived table. So we're going to start with select star. So I could just simply run this. I have to give it an alias. So I'm going to call this OT, short for order total. And I could just run this and get exactly what I had before. So this is the source of my data. Or I could join out to my customers table. Now because I didn't list my customer ID here, because I don't have it, I'll have to join this to orders. Or I could do my join inside here and include my customer ID. Then I could just join straight to customers. It doesn't really matter either way. So we're going to do it on the outside. So from order totals that I calculated, join two orders. Actually, let's talk about this. If we want to see each customer, we need to start in customers and do a left join. So from customers, see, left join orders on the customer ID. And then we're going to left join to our order total calculation. So the order's order ID equals order total's order ID. And then I can display the company name. I want a grand total of all orders, so I can sum ot.order total, and then I can average it. Still have to do my group by. So there's my company name, my grand total, and my average order total. So here's my derived table. I join to it. Another way we could use this is if we wanted to display the products, but also display the order totals. So normally we can't include the summary and the detail level together. So this is going to be my same derived table. So select star from call that OT again for order total. And I'm going to join that to order details again. And those are going to join on the order IDs. Then I'm going to join to the products. So here I can list p.product name. Let's include the order ID. Product name and the order total. Where order ID equals 10250. So this is how we can get the detail and the summary in one query inside of SQL. Otherwise, we'd have to do this in Access. Okay. So that's our derived table. Now let's talk about correlated subqueries. So in a correlated subquery, the subquery can't stand alone. It is actually tied to our outer query. Kind of acts like a function. So the inner query is executed one time for every row processed by the outer query. And we actually have to build a reference in there. So let's go back to our example with chocolate. Rewrite the query of products ordered with chocolate using a correlated subquery. so this is the uncorrelated version, I can run this subquery independently. If I want to turn this into a correlated subquery, I could do this with in. So I'm going to copy this. So what happens here is when I want to correlate it, I need to use different aliases. So I want to tie this order ID to this one, but I can't use OD in both. So I'm going to call this one OD1. And then in my where clause here, I'm going to say and OD1 dot order ID. So the order ID from this copy of order details equals the order ID out here. So if I try to run this, it tells me that OD.orderID can't be bound. It means it's not found. It can't figure it out because it's out here. It's not in here. But when I run this, it works. I get those same 8 rows. It's basically doing a lookup. So that's the same thing with in. And I can also write it with exists. So it's a similar thing. So instead of saying the order ID is in this list, I say exists. And because I've already tied these together, what happens is for each row, it says, does this order for the row up here exist in this query? If it does, return it. So this returns a true false versus an order ID like it does up here. So you could also do not exists. So if you want to not in, not exists, same thing. In some cases, exists will perform better for you. With very small queries, they tend to perform the same. So another way we could do this what products generate more profit than the average profit for products from the same supplier? So that's a little bit of a mouthful and confusing thing. So basically what we want to do first is calculate the average profit by supplier. From suppliers, join products. The supplier's supplier ID, so I'm going to put star so I get my IntelliSense working, and I'll come back and clean that up, equals the product supplier ID. So I want the company name as a supplier, and then the average profit. And I need to group by my company name. So average profit for each supplier. Now I want to know what products have more profit than the average for each of their suppliers. So for products supplied by Bigfoot breweries, which products have more profit than those? For products supplied by Exotic Liquids, which products have more profit than this? So that's where we need to correlate these things. So I want to know the product name, and we'll show the average profit. So where, group by the product name, having this average profit and here what I want to do is I want to select the average profit. But I want it to be dependent on the supplier. Move this down so I can see it. So where, from products, I'm going to call this P1, where P1 dot supplier ID equals whatever product we have on the outside, supplier ID, P dot supplier ID. Again, I can't run this subquery on its own. It's going to tell me that a lot of this stuff can't be bound. That's because I need to use the right aliases here. But it should just tell me this supplier ID can't be bound. But when I run it this way, I need to include that here. And I also need to group by it. So it'd probably be a good idea to include our supplier name here. Supplier ID. Okay, so the supplier's ID, the company name, product, and the average profit. And I need to group by. That's why it's generally a better idea to write these things separate and then put them together. So Exotic Liquids, 2 items. I can order these. They are ordered by supplier, so we can see there's some for most of the suppliers. So this is one we really couldn't write if we didn't have a correlated example, correlated subquery here. So we can nest subqueries. So we could have a subquery. We could have another subquery inside of here and another subquery inside of that. You can do it up to 32 levels. You should never, ever, ever nest anything that deep. It can cause serious performance issues when that occurs. I wouldn't recommend going more than 4 or 5 levels deep, and even then you can cause lots of performance issues. So I will post these to Blackboard. I know that this is a little bit confusing, so when we get to class, we will do some more examples on subqueries. I will see you in class.